All right, so in this video, I'm going to show you guys how to use our sweet 36x to get a table of values. So I'm going to go ahead and look at problem 46 here. So problem 46 says that Marissa is home, the distance that Marissa is home, oh my God, I'm starting this over. All right, so in this video, I'm going to show you how to use the TI-36X Pro for finding a table of values. We've been doing this extensively in class, but I'll just make a video to walk us through doing this. So in this particular example, I'm going to have us look at number 46 here from the book, so I'll cover up the stuff around it. It says that the distance that Marissa is from home after 8 hours of riding her bike can be estimated using this equation. So I'm going to write this down so I can get rid of this book in a second. 8h plus 2. Where D is the distance from home in miles, and we're going to create a table of points that make sense and graph them. So we'll connect the points with the smooth curve. So we want to make a table. We know we can make a table by hand by just plugging in values. And what we want to plug in is our x. So this is not set up the way we would normally think to have this set up, but it's fine. We know that usually this looks like this. Y is equal. Magically, the book is gone. Not magic, the power of pausing. So anyways, I'm trying to get this to focus again. We're now here. We know what our equation is. We know that our D is just going to be our Y, and we'd like to plug in. So we need to press the table value to get our table. And we want to, once we're in the table section, we want to go down to Edit Function and then press Enter. So again, I'll just walk through that in case you missed it. Table, because we want to make a table, no need to press second or do anything else. And then go down to Edit Function. And here's where we're going to put in what our function is. So this is our output. We need to tell it to take the input, our x, I'll clear it, and then multiply it by 8, and add 2. So now I have my 8x plus 2. So remember, just think of this as just being interchangeable for x because it's our input variable, whereas d is interchangeable for y because it's our output. Once you press enter, you have 3 different settings you can play with. You can say where you want your table to start. 0 is always a good place. You can tell it what you would like your table to step by. So I'm going to go with 1 because every 1 hour starting at 0 makes sense to me. And then the last piece is, do you want your table to autofill or do you want to use the input button? So I'm going to leave it at auto, and I'm going to go down to calculate and press enter. So 0 and 1 are great settings, auto is great, press calculate. Now we have a table with all of our values in it. We can scroll up and down and we can see exactly what distance she's going to be from home. So before she even leaves home, she's somehow 2 miles from home. This doesn't make any sense. That's what our intercept would mean, but whatever. Maybe it's arguing that we should only be looking at positive numbers, right? So an hour after she leaves, she'll be 10 miles from home. 2 hours after she leaves, she'll be 18 miles from home. And we're just adding 8, so we can recognize the pattern now. So we may not have to keep using the table. But that's using the table in our calculator. So we can use it for things that don't even have y's and x's. We just have to think of it as input and output, and we're still able to use this. So I'm going to pause this for a second, and I'll be right back to show you how to do this for a more mathy question instead of a contextual question. All right, so our more mathy question is here. Now we want to make a table to graph a linear function here. No context, nothing to help us out. And I've made it even worse because it's not solved out for y. So if you have something like this, the very first thing you need to do is solve for y. So as we've done in class, we're going to undo this by reversing our order of operations. So first thing we're going to do is get rid of this 2x. We can isolate the 3y. It has to be subtraction because it's being added to the 3y. And then we get 3x is equal to 8 minus 2x. They are not like terms, so they can't combine. And then we'll divide by that coefficient. Y is equal to 8 minus 2x divided by 3. Like I said, no reason to put this in slope-intercept form to make it prettier. Anything else you do, you might potentially make an error, whereas right now I feel pretty good that I haven't screwed anything up. So now I'm going to go back to table. I'm going to edit my function. I'm going to clear out what's in there, and I'm going to type in this. I do want to make sure that it is in a fraction form, just like I have. So I'll use the fraction button. 8 minus 2x, and then divided by 3. Looks exactly the same. I can change my start and stop, not my start and my step, but they again are probably fine. And I can press calculate. And you can see here, we're having some ugly values, some fractional ones, but we're able to get out a nice table. So if I were to put this onto a test, I would go, okay, first x and y pair that looks good is 1, 2. Then I have 4, 0. 7, -2. And hopefully by now I'm already starting to see my pattern. It looks like I'm subtracting 2 each time as I add 3. So the next one's going to be 10 and -4, which I can confirm by looking there. And if I want to go the other way, instead of subtracting 2, I would add 2, so I'd have 4. And instead of adding 3, I would subtract 3, so I'd have -2. So -2, 4 must also be on my list. And there it is. So this is just how we can use the table, and we can move around. Now we might have a contextual question or a question where we want to know, say, plug in 4,000. We had that one on the worksheet today. So I'll pause and then I'll show you guys that last thing we could do with the table in this thing. All right, so the last thing I want to show you about the table. In number 5 on the worksheet from today's class, we had this guy working at a restaurant. He earned $1,200 a month. So that was his base amount that he earned, plus 20% of whatever he sold on tips. So we have his base and then his amount in tips. So the thing that's going to vary every month is going to be the amount of tips he gets, which will vary based on the amount of money in meals he sells, and Y is going to be his monthly salary. This is the first one where they really didn't define those two pieces for us, but there we have them. What happened is when you went to the next step, it said use this to find how much he'll earn, his salary, if he sells meals worth $4,000. So we were given an X of 4,000. And we were asked what is his Y. Now obviously we could take this and plug it in and just do the math by ourselves. But if this were part of a larger question, it might be nice to know how to use our table so that if I type this thing in, 1,200 plus 0.2 x's, that I don't have to sit there and then go, oops, did it save? Dang it, 1,200 minus 0.2 x. That when I go in here, if I start at 0, I don't have to go in and go all the way to 4,000 because that's not going to make any sense at all, right? Instead, what I would want to do is go back a step, and you can go back a step by pressing clear. And you can either say start at 4,000, that's completely legit. So now when I go in to calculate, the first thing it pops me in is at 4,000. I must have a typo. 1,200 minus, dang it, plus, sorry, guys. I just typed that in wrong. This whole thing is going to get so sad. 4,000. Did I change it? No, I did not. Crap pants. Let's just start this all over. So in this video, I'm going to show you how to use the TI-36X table function for a lot of different applications. So first off, an application question. So this question was about some girl named Marissa, and it said that D was the distance that she could bike from her house after H hours. So they gave us this equation, and we could interpret all the pieces of it if we wanted to, but what I want us to see right away is that we still have an input, which we can think of as our X, and we still have an output that we can think of as our Y. So even though this doesn't have an X and a Y, we can still use X and Y to represent our D and our H, our input and our output. So if I input how many hours it's been, I can get out the distance from the house that Marissa is. And if I have that, then I can use a table to go ahead and do this for me. So in your calculator, I'm going to press table because we want to make a table. Don't press second. Don't do anything else, just table. You should see the function table show up. We want to edit the function. So inside of my edit function, I can pop in 8x, let me clear that out, plus 2. Once I'm done, I get to press enter. And then I can tell it where do I want my table to start. So usually 0 is a good starting point. Yeah, starting 0 hours. That makes sense? How often do I want my steps to be? So right now, what I am telling my calculator is that I want you to start with 0 and then count by ones. And that makes sense when we're talking about this context. We would want to start at 0 hours and then add an hour each time. And then I can go ahead. Auto is good. It's going to auto-fill my whole table for me, output my distances, and I can press calculate. So I can see somehow at 0 hours, she's 2 miles from home, which honestly makes 0 sense, but whatever. At 1 hour, she is 10 miles, then 18, and we can see that adding of 8 going on here. So you keep going down, 18, 26, 34, just counting by 8s as we go down. Okay, well, what if we had a question that said, when will she be 20 miles from home? Maybe she needs to go to a friend's house who lives 20 miles away. You can tell that 20 miles isn't in our table. It's somewhere here, right? Somewhere between 2 and 3 hours, which would probably be enough for a normal human. But on a test, I would want something better than that. I would give you partial credit for somewhere between 2 and 3 hours, but I want something more accurate. So one option you have, besides doing the actual math, which would just be to plug in 20 here and then figure out what the h is. But one option would be to go back to your table. And in the second place, maybe start at 2, and maybe let's change our steps to like 0.1. Because now I'm asking it to make a table that starts at 2 and then does 2.1 and 2.2 and 2.3. It's basically allowing me to do guess and check, but without me having to do the work. So I can go in and say, let's calculate. And I'm looking for 20. Okay, well now it's somewhere between 2.2 and 2.3. If I wanted to, I could even get more exact than that. But at this point, I have a very good approximation. I could even go further if I wanted to, or I could figure out how to do the math. But you could see again, so if this is 2.2 is 19.6, and then this one is 20.4, somewhere between these two. In fact, it's exactly halfway between them. So the actual answer, if we went a little bit further, is actually 2.25 hours. But that's how you can kind of use the table. If you're looking for an output, you just search here and figure out what the corresponding input was. If you wanted to know how long it would be before she would, after 10 hours, how far would she be, you can go in and have your table start at 10. Let's change my step back to 1. And it tells me she'll be 82 miles from home. Somehow she's still riding a bike. 10 hours later, the exact same pace, hasn't slowed down at all. She's a machine. So at some point, it doesn't make sense to keep making this table because there's no way practically she's riding her bike at a consistent 8 miles per hour. But you get the idea.